Hi guys, let's see today's question. So today's question is based from the topic of statistics, in which there is a concept which is called standard deviation and variance. So the question which we have today, it says the variance of first 50 even natural numbers is what? Right? So before starting with the question and understanding the solution for variance, let's first understand the concept of standard deviation and variance, and then also we'll see how do we get the formulas and how do we derive that. So in case during the exam also, if you can't remember the formula, you may be able to derive it quickly, and then you can find out the standard deviation as well as the variance, right? So first of all, let's understand the concept of standard deviation. Then we'll find how to find the standard deviation and how to derive its formula. And then we'll see the question, that is the variance of first 50 even natural numbers, right? So starting off, the first thing, remember, variance is nothing but the square of standard deviation. So whatever is the standard deviation, if I just square it, I get the variance, right? So first of all, let's understand what is the standard deviation. So defining the concept of standard deviation, basically, if you have some observations, standard deviation basically defines how the observations are, or how the terms are deviated from their mean value of the observations which are known, right? So basically, standard deviation is nothing but the deviation of the terms from the mean value, right? Now, for example, if I have, let's say, 1, 2, 3, 4, 5. Now, if I have 5 terms with me, the mean value, if you understand, is 3 for this list. And we basically calculate how these other terms as well as 3 is deviated from the mean value, that is 3. So let's understand the calculation of standard deviation. How do we calculate this? So if I talk about the calculation here of standard deviation, the first step involved in the calculation is calculate the mean of the list which is given to us, right? So here I will simultaneously solve one example. I'll take this example only 1, 2, 3, 4, 5. So let's find the standard deviation of this by calculation. So calculating the mean first, mean of this list, if you know, that is sum of all. So 5 plus 4, 9, 12, 14, 15. Dividing it by 5, so mean becomes 3. Second step, calculating the difference of the terms from the mean value. So find difference of the terms from the mean value. So if I find the difference of the terms from the mean value, so I'll calculate the difference of each term from the mean value. So 3 minus 1, it gives me 2. 3 minus 2 gives me 1. 3 minus 3 gives me 0. 3 minus 4 gives me minus 1. 3 minus 5 gives me minus 2. Right? So these are the difference of all the terms from the mean value. Third thing, square those differences. So now if I square this differences become 4, 1, 0, 1, 4. After that, once you square them, calculate the mean again. So for the squares which you have calculated, again calculate the mean of those squares. So that gives me, if I calculate the mean of the squares, it gives me 4 plus 1, 5, 0, 6, 10. So it becomes 10, and the number of terms are 5. So it becomes 2. And then to find the standard deviation, what you do is take the square root. So once you take the square root of that mean, that gives you standard deviation, right? So this is the idea how to calculate standard deviation. Now let's derive the formula also for this. So I'll derive it here only. Let's see. So if let's say there are 5 terms here, so let's say I have my terms as x1, x2, x3, x4, x5. So let's say there are xi terms where I goes from 1 to any number n. right? So if I want to calculate the mean, how do you calculate? You take the sum of all these elements and divide by that many number of elements, right? So let's say there are n number of elements. So mean becomes summation of xi, that is I am adding all of these terms upon number of terms. So basically now we'll denote this mean as x bar, right? So this is the denotation of mean we are using, that is x bar. Now finding the difference of the terms from the mean value. So if I find the difference of each term from the mean value, so I am finding x1 minus x bar, x2 minus x bar, x3 minus x bar, x4 minus x bar, x5 minus x bar, right? So I am finding the difference of all of these terms. So I am finding x1 minus x bar, x2 minus x bar, x3 minus x bar, x4 minus x bar, and x5 minus x bar. Further, it says square them. So see, how do you calculate the difference does not matter. You can calculate it from the mean also, or you can calculate from the term to the mean also. Because squaring them already makes it positive. So that difference of the order which you are using does not matter. So now if I square the differences, so I'm squaring each one of the values which I have got. So if I square them, I get the square of these terms. So I get the square of these terms. After that, it says again calculate the mean of those squares. So if I calculate the mean of these squares, basically mean is what again? I am adding all of these squares. So I'll be adding all of these terms, dividing it by number of terms. So number of terms are 5 again, as in this case. So here number of terms are n because we have n number of terms. So if I calculate the sum of all of these terms till n, I can also write this as summation I equals to 1 to n, and this becomes xi minus x bar the whole square, right? Because we are finding the sum of these squares. So I am just writing instead of x1, x2, x3, x4, x5, I am just writing it as xi. So you can use any number of term from 1 to n and dividing it by n, because n is the total number of terms I have. And after that, if I take the standard deviation, I just have to take the square root of the previous thing. So if I want to find the standard deviation here, I'll just take the square root, and this gives me the standard deviation. So basically, if you understand it, I'll write it on the next page. We have also understood how to derive this formula, and that is summation of I equals to 1 to n xi minus x bar the whole square upon n, right? So this is the formula to find the standard deviation. Now there's one more formula. There is a simple formula also to calculate the standard deviation. Let's also derive that. So if I want to derive that, I can use this idea. I equals to 1 to n. Sum of I equals to 1 to n. If I square this, you already know a minus b the whole square is a square minus 2ab plus b square, right? So here if I use that idea, I get a square minus 2ab, so minus 2 xi into x bar plus x bar square upon, right? Now if I further want to solve this idea, I will take all of these summations separately with all the three terms. So I get summation I equals to 1 to n xi square by n minus summation I equals to 1 to n 2 xi x bar upon n plus summation I equals to 1 to n x bar square. It's not xi square, understand that? That is x bar square, that is mean square. Now, if I further want to solve this idea, write it here. It becomes summation I equals to 1 to n xi square upon n minus, if you understand here, the mean is a constant thing, 2 is also a constant thing. The only thing that is changing as per this sum is xi, right? Because I varies from 1 to n. So I'll take 2 and x bar out. summation of I equals to 1 to n xi and upon n plus, here also if you understand x bar is a constant term, so I'll take it out, x bar the whole square, summation I equals to 1 to n, and nothing is left, so 1 upon n. Now further, what you get here is first term remains same, summation I equals to 1 to n xi square upon n minus 2x bar upon n. Now here, if you understand this, it says you are adding xi from I equals to 1 to n. So basically whatever the terms we had that were x1, x2, x3, x4, x5, you are adding all of these 5 terms. So adding all of these terms, dividing by n. So I will not write it n here. We already know that idea that if we add all of these terms and if we divide by number of terms, it gives me the mean, right? And mean we already denote it as x bar. So I get it here as 2x bar into x bar. So that is the idea. And the further thing, if I solve it, x bar the whole square upon n, summation of all the terms or summation of I equals to 1 to n for 1 means you are adding this term 1 how many number of times? N number of times. So if you add 1 n number of times, what do you get? You get n only, right? If you add 1 2 times, you get 2. Likewise, if you add 1 3 times, you get 3. So if you add 1 n times, you will get answer as n. So if I substitute instead of this sum, if I substitute here as n, this gets cancelled again. So what I get further is summation I equals to 1 to n xi square by n minus this becomes 2x bar square plus x bar square. So minus 2 and plus 1, if you see it is the square of the same mean, it becomes summation I equals to 1 xi square by n minus x bar square. Right? So this is the simple developed formula. I'll write it on the next page. So we have understood two formulas to find the standard deviation. That said, root of first was summation I equals to 1 to n xi minus x bar the whole square upon n. But a simpler version of this that you can use is summation I equals to 1 to n xi square upon n minus x bar square. Let's see how to solve the questions using this formula and how simple it becomes now. So if I talk about xi square, it is nothing but sum of all the terms of xi square, that is all the observations squares. So for example, if I have, let's say 1 2 3 4 5, so I will square all of these observations. So summation I equals to 1 to n. If I want to make you understand this xi square, it's nothing but square or sum of all the squares of the terms. So if I find the squares, it is 1, 4, 9, 16 and 25. If I square them, sorry, take the sum of them, it becomes 41, 50, 54, 55. Now, what you do is after this divided by number of terms. So if I divide this entire entity by number of terms are 5 here. So 55 by 5, that gives me 11. Further, it says x bar the whole square. X bar is nothing but what? The mean of the list. So mean of this list is 3. So 3 square, that is 9. So I can just put in the answer and I get the standard deviation directly, 11 minus 9. So it becomes root 2. This is how simple it becomes when you use this formula. So we have understood how to use this formula. Also, we have understood how to derive this formula. So in case during the exam, if you forget the formula that we are using in standard deviation, you can just derive it during the exam and then use the idea to calculate the standard deviation. Now, instead of this, if we had variance to be calculated, we already discussed during the start that variance is nothing but square of the standard deviation. So variance is nothing but square of standard deviation, and we already discussed standard deviation was defined by root of xi minus x bar the whole square sum upon n, or root of summation of xi square upon n minus x bar square. So if I just take out the square root from this formulas, I get the variance, right? So it becomes summation I equals to 1 to n xi minus x bar the whole square upon n, or I can directly write it as summation I equals to 1 to n xi square by n minus x bar square, right? Where x bar is the mean of the list of terms. So this is how you calculate the variance. Now let's understand the question which was given to us and see the solution for it. So now let's see the answer to the question which is asked to us. It says variance of first 50 even natural numbers is. So if I first define what are the even natural numbers starting from, it starts from 2, 4, 6, 8. And if you talk about first 50 even natural numbers, it will go up till 100. So these are my first 50 even natural numbers. I want to find the variance of that. So variance of that set, summation I equals to 1 to n xi square by n minus the square of the mean, right? So first of all, let's find the mean, and whatever we get the answer as the mean here, we'll just substitute it in the formula. So we'll find these two entities separately. So if I first find the left hand side part, it says summation I equals to 1 to n add xi square and divided by n. We already know division is consisting of dividing it by n, that is of 50 terms, because we have 50 even natural numbers with us. Now if I find the sum of xi square, means I will square each term from 2 to 100, each even number, and that is added. So if I find the common term here from each of them, I can see 2 square can be taken out common because all of these are even natural numbers. So if I take out 2 square common, what I get is 1 square plus 2 square plus 3 square plus 4 square up till 50 square, right? Now, if you know the formula for this, sum of squares of first n natural numbers, right? This was n into n plus 1 into 2n plus 1 upon 6. So if I use that idea here also, it gives me 2 square into n is 50, n plus 1 is 51, 2n plus 1 is 101 upon 6, and this 50 already present in the denominator. This cancels with this. 2 square I can cancel with 3 here. This gives me 51 into 2 into 101. I can also cancel 3 with this. 3 ones, 3 17s. So 101 into 17 into 2. So 101 into 34. Right? So 34 ones, 34. 3 here. 34 zeros, 0. So 3 and 34 ones, 34. So I get 3434 here from the first part. Now let's calculate the mean of the list. So if I want to calculate x bar is what? Summation of all the terms from 1 to n dividing it by n. So if I add all the terms, I have 2 plus 4 plus 6 plus 8 till 100 upon number of terms are 50. So if I take 2 common from the entire list, I have 1 plus 2 plus 3 plus 4 till 50 upon 50. So 2. Now we already know again the sum of first n natural numbers is given by n into n plus 1 upon 2. So it is n plus 1 upon 2. So this cancels with this. Already 150 was present. This cancels with this. I get the answer as 51. So x bar in this case is 51. So if I just substitute it now, so x bar is 51, x bar square becomes 51 square. And 51 square, if I find it out, 51 and this is 5 and 25. So it becomes 2601. So if I just put it in the value, I get the variance there. And the variance is nothing but subtraction of both of this. So 3434 minus 2601. 4 minus 1 is 3. 3 minus 0 is 3. 34 minus 26 is 8. So the answer for this question becomes 833. And if you see the options here, the option that matches with this is B, right? So the correct answer in this question is option B. I hope you have understood this, how to find the standard deviation now for the list of terms, how to find the variance also for the list of terms or of the observations which are given to us. So this is the idea which we have discussed, that how to derive the formulas for standard deviation, how to find the variance. It is nothing but square of the standard deviation. And then we have seen the question of first 50 even natural numbers wherein we found the variance of that, right? I hope you have understood this very well. We'll meet again tomorrow with the next question and next concept. Till then, you can like, share, and subscribe if you found this helpful. Thank you.